Welcome to Study Loop.
So problem 8.89, this is actually a pretty cool example of just how powerful the conservation of momentum can be, because this is how a new type of elementary particle was discovered in the early 20th century. It was noticed that in beta decays, which is where a nucleus of an atom emits an electron and gains a positive charge, and this becomes the nucleus of another element. In this case, we're looking at bismuth 210 decaying into polonium 210. And it was found through experiments that the momentum is not conserved. In this case, this is starting at rest, and the momentum of the electron is not equal and opposite to the momentum of the polonium nucleus here. And it was suggested that perhaps the conservation of momentum isn't always true. But Wolfgang Pauli actually was like, well, maybe there's this other particle that is getting emitted and it's hard to detect. And he turns out he was right. It was sort of a bit controversial because it's like, well, okay, you say this exists, but like, where is it? It just turns out that neutrinos or antineutrinos in this case is really hard to detect. Anyway, getting to the problem itself, we know that the momentum of our polonium nucleus plus the momentum of our electron plus the momentum of our neutrino. This is the Greek letter nu, by the way. This is an antineutrino, so technically there should be a bar over it. This has to equal 0. Now, since these are both moving in the x direction, there can't be any y component to the momentum of the antineutrino. So this is just for the x components of these. And yeah. So the momentum of our antineutrino, that looks like a D. Let's just call it a neutrino. It doesn't really matter for our purposes. Is just the negative of the momentum of polonium nucleus minus the momentum of the electron. Fairly easy. So we put all of these numbers in, and we find out that we get a negative 1.61 times 10 to the negative 22nd kilogram meters per second. So it's moving off to the left. So we might draw our neutrino out here. It should be level with these, but there's only so much space. Put a bar over it since over here there's enough room. And yeah, you can see that actually the electron's momentum is 5.6 times 10 to the negative 22nd kilogram meters per second. And this is the same order of magnitude. So there's quite a lot of momentum that's missing from this polonium nucleus, you can see. So this was quite a mystery for a while, but then they eventually solved it, and then they eventually found out that the solution, the neutrinos and antineutrinos, also actually exist. So it was a solution that actually works.